Okay, welcome back from the break, everyone. I will continue here for a little bit, after which Dave will give you the first actual hands-on Python lesson. I hope you can see my screen well, and I hope my mic is okay. I had some problems with it yesterday. So I would like to start from Slack. Some of you have already signed up there, but if you haven't, you could now join Slack if you want. So we sent the join link in the email yesterday. If you haven't used Slack before, you might have to then verify your email. So latest during the first exercise, you will get familiar with Slack. And while you are doing that, so I could show a bit what is Slack about and what we are using it for. So as we are teaching online this year, this is the main channel for communicating amongst ourselves during the course. And Slack is organized so that we have different channels. So you should all be by default added to the general channel, and then these weekly channels on the left side. And then in addition, there's a channel for whatever random things you want to post online. But basically, if you have general questions, general announcements, you can find them from the general channel. And then, for example, questions related to this week, you can post to week one channel, and we could try it out. So in case there's somebody who hasn't received instructions for joining Slack, now is the time to maybe ask in the Zoom chat, or then afterwards you can send an email to either me or Dave if you haven't been able to join Slack. So yes, so Dave also shared the link there. So from now on, we won't be sending too many emails to you. We will send all important messages in here. It's pretty simple. You can say hi if you want. You can also tag people if you want to ask something from a friend or from some of the assistants. And I think there is also, I could notify everybody who's active currently. So now if you are on Slack, you might have received a notification in there. So I know that most of you are probably working on a laptop. So if you're able to arrange your screen so that you can maybe minimize Zoom at some point and only listen, or also if you want, you can just follow. So from now on, we'll be doing some hands-on stuff in the browser. Okay. Okay, and there was some private chat. And then threads is one way to keep things organized. So Dave has now replied to my message in there. And then I can reply there. So if you have, for example, a question about exercise 1, part 1, how do I sign up to GitHub, then the same discussion could then go under a thread, or if you have a new topic, you can post a new message to a channel. So pretty simple. So I could invite you if you want. Whoever is online, you can come and make your reaction to my post in the week one thread, just to show that you're following. Great. Okay. So I can't see any questions in the Zoom chat related to Slack. So maybe from now on, if you have some questions, of course, during the Zoom lessons, you can always ask on the chat platform. But if you ask on Slack, then the questions will stay there, and we can then reply also later on, and the questions will be then visible to also other students who might be having the same question. So maybe three guidelines for using Slack: use it actively, don't hesitate to ask. Often if you have a question, some other student also is wondering about the same thing. Feel free to help each other out. So if you know the answer to a question, go ahead and answer. So of course we will be mainly answering during the exercise sessions, but also feel free to ask anytime, then we will answer as soon as somebody sees the message. And maybe one final thing, so when we get to programming, so please don't post solutions or exact solutions, long code blocks, not to spoil the fun to other people. So maybe you can then share some code via private messages, which you can find down here, or then you can ask somebody to go to your GitHub repository and check the code there, for example. Okay, so you can continue discussing over there. I will switch back to the course webpage. Before the first programming lesson, we of course need a place to write our Python code. And information related to that can be found under lesson 1, course environment, over here. And as you can see, we have a long list of different platforms that we will be using for programming and for communications. And don't worry, you will get familiar with these different tools along the way. And today we will start using a development platform called JupyterLab. And for that, for now, you don't need to install anything. We will be doing the coding on the browser. And I will soon show you how to access this programming environment. Yes, so maybe at this point, I will soon come back to this course environment page, but I will also open this first lesson, which is the taste of Python under lesson 1. So again, you can, if you just want to watch, I can show you first how this works, and then you can try yourself a bit later when Dave starts. So our lessons are actually, all the codes are visible here on the web pages, but we can also interact with the code in different ways. So I will show you some options, how to make this page interactive. And by default, students in Finnish universities or Finnish institutions can then use a service provided by the IT Center for Science, so the CSC Finland, which I will show shortly. But then also at the top of the page, you have this little rocket button with a link to Binder, which will make the page interactive in a new tab, or then ThebeLab, which will then make the code cells interactive on this web page. And Dave might introduce these two options while doing the lesson. But I will go back to now to this course environment page and scroll down here. So you will soon see when we start programming a view that looks something like this. And this is the basic view of a JupyterLab environment. So it's the place where we will be writing our code, interacting with the files, and so on. And you will be able to open this in a browser window then via these different options. Basically, if you have, for example, used R, you might have used RStudio. So this is a bit similar. The main kind of file type we are using during this course when doing the programming are Jupyter notebooks. So Jupyter notebooks are interactive files where you can have basic text and then these blocks of code which then actually interact with the Python interpreter on the background. So this is the basic view we will be having during the lessons and then also for the exercises. Great. So then I will scroll down here and show you how we can get started with CSC notebooks which is then indeed now only available for people with an account at Finnish higher education institutes. So I will show this first, and then I can repeat in case some of you are doing it along and didn't follow. So we will go to a page called notebooks.csc.fi. In here, I will open it in a new tab, and you will be asked to sign in. I'm already signed in here, so I'll wait a bit. You can use the Haka authentication and put your regular university credentials in there. So when doing this for the first time, you will see different environments, which are for different purposes, for different courses and such. But our course has our own group. So for that, in order to join that, you need to go to the account tab. So once logged in at notebooks.csc.fi, you go to account tab, and then there's this button join group. And for that, we need a code, which you can find on the course environment page. I'll also post it to the chat box over there. So account, join group, and then I'm pasting the code. And this you only need to do once. So once I did that, you go back to the dashboard, and then you should see some familiar course names appearing on the dashboard page. So we have some options with different settings, but today and by default during the first teaching period, you would be using this Geo-Python environment. And once you manage to join the group, you can launch this environment from here. Let's see what happens. Okay. So you should see something like this. It might take a few moments to build. And now that we are many probably doing this at the same time, it takes a bit more time. But once it's ready, you will see a link appearing under the access title in here. And this workflow that I just showed can be found here under CSC Notebooks. When logging in for the first time, we need to join the group. And then every other time, you just go to CSC Notebooks, launch an instance, and then open the instance in the browser. Let's see how it's coming along. Da-da-da. Okay, I might do this that I come back using. Okay. Coming from my admin view, launch. I see many of you have succeeded to launch the instance, so that's great. I have time to wait for the other instances also to launch in the meanwhile. And maybe while waiting, in case you ever have problems, so you have the options that I quickly showed before. So at the top of each lesson, this is the link to the same place that we were before, so CSC Notebooks, but you can then also launch a similar environment through this binder link. The only drawback is that it only works in the browser, and you might then lose your work in case your internet connection fails, for example. Let's go. So here, once you got this open in browser link, you click to copy the password. Then you can Ctrl-V, paste it, log in. Don't need to save the password. And now you have this JupyterLab development environment open. Dave will soon continue from here, but I'll just quickly show. So we have some folders here ready for you. Exercises is still empty in your case. And then the notebooks folder will have all the lesson materials. So you can go to notebooks folder, lesson 1, a taste of Python, and you will have this interactive Jupyter notebook file ready for the lesson. I hope this didn't go too quickly. You have all the instructions here on the course environment page. I think I'll at this point pass over to Dave, and I will be on Slack and the chat as answering questions in case there are any.
Okay, yeah. Thanks, Walko. Maybe, are there any questions at the moment? I see a lot of people have gone to the CSC notebook system and opened their instances. It looks like most of them have, as far as I can see, I see them all running now, so that's good. There's no one who's stuck in the queue or in some other kind of bad state. But as Walko mentioned, if you're having any problems, if there's, for some reason, your CSC notebooks instance isn't launching or you can't log in or whatever, just let us know in Slack or in the Zoom chat. I mentioned it in the Zoom chat already, but it's fine to ask questions there. We prefer to have the questions in Slack in general, just because that's maybe easiest for us to be able to keep the questions after the Zoom sessions end. But if there's nothing urgent right now, I will switch over to sharing my screen once again. I guess you should be able to see it now. And I'm going to drag down my, let's hope this works. Yeah, so we are here. I have my CSC notebooks instance now visible on my screen, and I guess you can see my screen. I'll also turn my video on in case you find that to be helpful in some way. And what we're going to do, as Walko mentioned in this part of the lesson, is now get our first taste of doing something in Python. So you should go here, if you're in the CSC notebooks, to the notebooks directory, and then also to the L1 for lesson 1 directory. And if you haven't already, you can open up this A Taste of Python introductory lesson. So this will be our first experience using Jupyter Notebook. And just to give you a little bit of an idea of, like Walko mentioned, kind of that there's these cells that can contain either nicely formatted text in it's called Markdown, or they can contain Python code. And the reason that we teach things this way, rather than just doing it in a kind of pure writing Python scripts or working in a Python interpreter, is that this Jupyter Notebook is a really nice place to be able to mix those two elements together. So we can have, for instance, our instructions for going through some lesson, our instructions about how to do one of the exercises in the same document, where you can put the code to answer those questions or follow along doing things. So this is kind of cool. I will say that for those that are at a Finnish university, CSC Notebooks is probably the preferred way to go and access things, to do the lessons and follow along with us, because we'll basically be doing this like a real kind of live coding experience. So I would say this is the preferred way to do things, would be to go and use the CSC Notebooks. But I will show you here, if you're on the Taste of Python page from our website, that you can go and you can do things like launch Thebe. So I'm going to click this live code button here. And then you'll see this thing pops up and says, okay, it's launching from my Binder. And Binder is a cloud computing system that exists that allows you to run things like Jupyter Notebooks on some cloud computers. This says it's now ready. What does that mean? Well, actually, what's cool about this is we can now go in here and on the course webpage do interactive things in Python. Like instead of doing 1+1, I could type in 2+2, and then I can click run, and we have an interactive code directly inside the webpage of the course. So that doesn't require you to launch CSC notebooks. That's just kind of a quick way to go and test things. The drawback here is that after a little bit of time, I think, I don't know for Thebe exactly what the time is, but it's something like maybe 10 minutes. Your connection to Binder will die, and then you're no longer able to interact on the web page. So that's a little bit of a drawback, I suppose, in this case. The other possibility is you can go here and just launch Binder, and when you click that, excuse me, this will open up a similar format to the CSC Notebooks platform. Things will look very similar to the CSC Notebooks, but you'll notice that you don't have to log in or anything like that. So anyone who's following the course who's not a student or affiliated with a Finnish university can go and use Binder. Click this link, and after about 30 seconds or so, we should be taken to a Jupyter Notebook that's running on Binder. So that's what's happening right now. And here we have now our notebook opening up. Here's our Taste of Python lesson, and you can see, for instance, here now the same notebook that we were just looking at in the CSC notebooks a moment ago. Again, I can go here to one of the cells, and I can press Shift-Enter to run the cell, and I can see that this is a live interactive notebook. Again, the problem here is that Binder, if you have about 10 minutes of idle time of not interacting with your notebook, the connection to Binder will die, and then you're in a position where you're no longer able to interact in that notebook. So it's a free service, it's quick and easy to launch, but it doesn't stay alive for that long. And because of that, I think the CSC Notebooks is preferred in general. If your Binder instance dies, there is an option here to save to browser storage. So you can click this little down arrow on the cloud to basically download your notebook. You could then relaunch Binder, and then you can click the button to upload to get back to where you were. But I would say in general, the CSC Notebooks is the way to, it's definitely the way to go in general. So just mention those two things quickly, and I'm going to leave this page, go back over here to my CSC Notebook instance, and to our first Jupyter Notebook. So the key thing here with the Jupyter Notebooks system is that we have our cells that contain some text in the form of Markdown, and our cells that can contain Python code. If you were to go on one of these cells that has a text in it, you could double click it, and that will then show you the Markdown formatted text that will produce the nicely formatted rich text that you see in the cell. And once you've clicked in this view, like you could go and change something, you could edit this. It is just an interactive document. There's nothing that stops you from doing any changes in here. But if you press Shift-Enter, it will then run that cell, which means it will convert it to the nicely formatted Markdown text. We'll talk a little bit more about Markdown when we get to the exercise today, but I won't spend much more time there. So let's jump into the lesson here, and we can talk first about some basic things in Python, like doing basic math. So if we go to one of our cells in here, we could do, for instance, 1+1. And again, you can press Shift-Enter, or if you prefer, if you're kind of a clicky kind of person who likes to click on buttons, you can go up here to the play button, and you can click play. And if you type in 1+1, click play, you'll see that Python does the calculation and returns to, if you did 5 times 7, the star here, asterisk, is used for the multiplication. you can press Shift Enter or the play button, and you should then see that you get 35, the expected answer there. So we can do that very basic math, adding, subtracting, division, whatever, no problem. We can also do things in Python using functions. And so there are functions like print that will display things to the screen. There's also some math functions like sine, so we could do sine of 3. And if you run this, you're going to see a name error, and that sign is not defined. We could also try square root of 4. And if I run this cell, I get the same thing. What's the deal here? So why is this not working? Python has a huge number of functions that are available to you, but the default set of functions doesn't include something like sine, doesn't include something like the square root. It's very stripped down to basic things. Print and these other kind of very basic functions are part of the default library of things you could do in Python. So here, when we type in the name of some function, in this case sine, and then we put in some value where we would like to calculate the sine of the value 3, it gives us a name error because it doesn't have a function available that it's can use called sine in the basic library of Python functions. Let's take a look at another example. So here, if we look at our math operations, this is the stuff we can do by default in terms of math in Python. Add, subtract, multiply, divide, and raise things to a power to do x. This is the worst word to pronounce. Even as a, as a native English speaker, I just struggle with exponentiation. It's a very weird word, but anyway, you can raise things to powers like 2 to the 3, and you find that you get a value of 8 from that. If you want to do more complicated math stuff than that, you have to tell Python that, hey, I want to use some extra math functions by doing something called importing a library or importing a module. So if we type here, import, and then the word math, this will load into our Python session the functions that are part of a library called math. So these are functions to do things like sine, square root, whatever. So I'm going to type import math and do Shift Enter, or you can click play. What that does is it now reads in these math functions to the memory of our Python session, so that now if we want to calculate the sine, we can type math.sine, and then our value that we want to calculate the sine of, in this case, 3. And so if I do math.sine 3, then I get some value here because it has gone to the math library. This is the name of the library we've just imported called math. And then from that library, it's taken the sine function. So when we use these libraries, we have the name of the library dot whatever the name of the function is that we want to use. Let's just take another look at one other example. So we could do math.square root, SQRT. And we could say math.square root of 4, and we expect to see the value of 2. Sure enough, that's what we get. And so here, again, we're using a function out of the library called math with the name of square root, SQRT, in its sort of short form for the name of the function. So in order to use the functions, just to recap here, first off, a module is the name of a Python file that has a bunch of related functions. So if you want to say a math module would contain functions that are related to doing math stuff. And if there's a group of them, they might be considered a library. It depends a little bit on the size and number of different things that are there. But there's not a strong distinction between a module and a library in Python, in case you've seen things in other programming languages. When we want to use something out of a library, out of a module, we type import, and then we type the name of whatever that module is. So import math. Then we can do math.something to use one of the functions from the math library. And for instance, going back to our example that we had typed in here with the square root, we can do math dot, and if you hit the tab key, the tabulator key, after doing math dot, you'll get a list of possible functions that are part of the math library. So if you don't remember what one is called, or you're not sure if there is a function for doing square root, I could see here scrolling through my list until I get to sqrt, click that, it fills in the name of the function, and then I can type in whatever my value is, 144, or whatever you want to choose to get the square root of some number. So that's, yeah, importing the libraries and using them. And in a Jupyter notebook, whatever you've defined earlier in the code will be available for us to use later on. So if I've imported math earlier, any cell that I use after that, I could use the math library without any problem. And finally, for the modules here, they're not only potentially having functions in them, but you can also have things like math.py, a constant that is part of the math library. So here I could type math.py and I get back the value of pi to, I don't know, 16 digits or something like that. So we have these different things that are all part of the math library: square root, sine, whatever. At this stage, we'll pause for a moment and you can check to see how well you've understood or how test out working with things in this Jupyter notebook here. So we've got an empty Python cell here below. This little number sign at the beginning is an indication of a line that is a comment. So everything that follows the number sign will be ignored. So this text here is basically just some instructions inside the cell. It doesn't actually do anything. So below here, though, we can calculate, for instance, the sign of the value pi. So why don't you see if you can type in your Python code to calculate the sign of pi, and maybe when you're ready, we never really did our introduction to how to use stuff in Zoom. I guess we sort of assumed you guys have been using Zoom a little bit. Maybe when you're ready, you can, let's see, in the participant list here, I'll move this off screen. You can put like the little checkbox for yes to indicate that you're ready to go on. If you're having a problem, you can put the X for no. And then that way, one of either Volko or perhaps Emil, if he's still here, Alex, someone can possibly send you a direct message and see what the issue might be. Normally, we would have some other way in the classroom to kind of indicate that you're ready. But you can just put the little green check mark when you're set, and then when I see a good number of green check marks, we can continue. Okay, so I see now we've got about half, a little more than half, who have given the green check mark, so that's good, and we can continue from here. So yeah, the task was to calculate the sign of pi, and again, just to know that you've done it correctly, it's a good thing to think about what did you expect for this calculation. As you may recall, the sine function is defined so that it's 0 at the value of sine of 0, goes up to a value of 1 at pi over 2, and goes back to 0 at a value of pi. So our expected value here should be that we should get something like math.sine of our value of pi should be around 0. And so, we could go here, we could copy the value that's output from our math.sine function and run things like this. And so I get a value here that's very close to 0, 1 times 10 to the minus 16. Not exactly 0 because our value of pi has been rounded, so it's possible it's close to 0, but not exactly. Alternatively, instead of copy pasting the number here, I could also do math.sine of math.pi. So this value that's in here is going to be converted to the number when the sine function is used, and I get the same answer if I run math.sine of math.pi. So yeah, I hope that you ended up with something similar to that. If you didn't, that's not a big thing to worry about, but just so you can see how things are working, I'll just show the example here math.sign is how we're going to use the sign function from math, and then the value we want to calculate is inside the parentheses here. All right, I'm going to clear our check marks, and we can continue now with our next step, combining functions. So in this previous example, we had combined here a function, the sign function from the math library, with a value from that library. But we can also combine functions together. So we can print out something like the square root of 4 using the print function. We haven't used this one yet, but its name is simply print. As is the case with functions, you have then parentheses to say what we should print. And here we can say math.square root of 4. So I'm just going to add one set of spaces on either side here just to make it easier to read things here. But we have our math.square root function inside here where we calculate square root of 4, and then we're going to print that value to the screen. Now, really, it doesn't do anything different than what we were doing before. When you did the square root function, it returned the value to the screen. Here, we're just explicitly printing that value. So why? There's not really much point to doing that. But with the print function, we could, for instance, print out something that says the square root of 4 is 2.0. So we could say print, same function we did before, and then the square root of 4 is, and so this is going to print anything that's inside these quotation marks. It will print out as a string of characters, so basically exactly this text inside here because it's inside the quotation marks. Then I can do a comma and do math.square root of 4. So this now is going to combine some text with a calculation. And if I run this then by pressing Shift Enter, I now see the square root of 4 is 2.0. So that's perhaps not a huge surprise, but that is the way in which we can combine a bit of text with a function inside the print statement. And already you can start to think, oh, okay, well, maybe that could be useful for displaying things to the screen. Like if I have some little program that's running and doing some calculation, I can print the values out to the screen with a bit of text so I know what those values mean. All right, now let's move to our next section about variables. And basically what we're talking about when we're dealing with variables is just assigning a name to refer to some value. So this is an easy way for us to remember what the value is rather than having to remember the number itself. I'm seeing some notifications in chat. Am I ignoring things? Where do we find the check in X? Yeah, okay, Wolk was already on this. Sorry, I'm behind it. Okay, so variables are basically just a name that can be used to refer to a value. So you don't need to remember the number value, for instance, itself, but you just remember the name of the variable. How do we use that? Well, we basically do an assignment by listing first the name of the variable. So let's here call our variable temp_Celsius. And we'll say it is equal to the number 10.0. And don't put quotation marks around this one, just put it in as 10.0. And so we're going to assign the name temp Celsius a value of 10.0. Then, if we want to print out our value from temp Celsius, we can then print out temp Celsius. And if I run this, I have 2 lines in this cell, no problem. We'll just run them both. First, it's going to assign the value 10 to a variable called temp Celsius. And then when I print out the value of temp Celsius, I see my 10.0 comes back. No surprises there. But clearly, this is a valuable thing to understand that in order to do the assignment, we have to have this equal sign, and that just basically will put this number to be associated with the name temp Celsius. So that variable name can be almost anything. It can't be truly any name you want, but it can be most any name, and we'll talk about that also at the end of this lesson. Now, what we can do is we can combine things like our variable values with our print statement and do things like our little temperature calculation, where we could print out the calculation of a temperature in Fahrenheit if we have a temperature in Celsius, so that I can know what clothing to wear to work. So, for instance, I could do a print statement here where I could put in quotation marks that temperature in Fahrenheit. You could just type F if you don't want to have to type in Fahrenheit, and then colon, and then now here I'm going to do a calculation of my temperature in Fahrenheit from my temperature in Celsius by doing a little bit of math here. So I could say temp underscore Celsius times 9/5 plus 32. And that's our conversion factor to convert our temperature in Celsius to a temperature in Fahrenheit. We multiply by 9/5 and add 32, and that will give us our temperature in Fahrenheit. If I run this cell, now, again, just pressing Shift Enter, I see temperature in Fahrenheit is 50 degrees. I don't actually know that 10 degrees Celsius is 50 degrees Fahrenheit. It sounds right. So it would be good to test this out in with some known values. So we can go back, for instance, here, and we could modify things. But for right now, we'll just keep it as is and assume that this is the correct calculation. It says it should be right here in the lesson, so how could it be wrong? Okay, so that's just another example combining now a variable with a print statement, and you can see how that works. Now you get another chance to check your understanding, and in this case, what we want you to do is use the print function once again, and all you have to do is define a variable and print its value to the screen using the print function, just to practice. And if you want, you can define a couple variables, try to print them both. You can add some text and print your variable, whatever you want to do here. But again, if you go to the participants list and you can add your green check mark when you're done, then we'll know that we can continue. Just a good chance to check in and see about assigning a variable and printing it to the screen. Okay. Looks like we've got about 30 plus now that have been able to do this, so that's good. Here we could just do another example where I could say, for instance, name equals Dave, and then do a print statement that says, my name is name. And again, notice here that this text within the quotation marks, even though I have the name word here that I've just defined to a variable, that will be treated as an explicit string of characters and not as the variable value because it's in quotation marks. And then the value itself will then be read here so that if I run this, I see my name is Dave. You could do whatever example you want there. It's kind of up to you. But that's a nice example just to see how things are working. All right, so now let's talk about updating our variable values. So the values that we've defined, for instance, for temp Celsius, are things that can be changed. For most data types in Python, this is the case. There are some that are not easily changed. But for instance, if we wanted to change our value of temp Celsius to be something different, we could say temp Celsius equals, let's go with 0.0 instead of the 15 that it says here. Let's make it 0 so that we can check and see if our conversion is working properly. So I can run that cell. It updates the value of temp Celsius, and then if I print out temp Celsius here in the cell below, type in print temp Celsius, and I see 0.0. Again, no surprises here. The point is just that you can update these values without any kind of problem. Now, if we were to run some code that used another variable name, for instance, temp Fahrenheit, that had not yet been defined, So if I wanted to print out temp Fahrenheit, if I try to run this, I get a name error. This is probably not a big surprise because the value associated with temp Fahrenheit does not yet exist. It hasn't been defined as a variable. So Python just says, okay, well, there's no value associated with this name, so I have nothing I can do. I'm just going to print out saying that that's the problem. Now, one of the things that's kind of neat about these Jupyter notebooks is that we could go and now define our value of temp Fahrenheit down below. So we could do something like, say, temp Fahrenheit equals 9 divided by 5 times temp Celsius plus 32. So we can do some calculation here, in this case, converting Celsius to Fahrenheit, and store that as the value temp Fahrenheit. So if I run this cell, that value gets stored in memory. And if I go back up to the previous cell and run this now, I can see that the value I get is 32 degrees. And I know that's the temperature of freezing of water in Fahrenheit, so that looks good to know that our calculation was done correctly. So the point here is that once you've defined the value, then if you run any cell after that, that value is available. And you can tell here, for instance, with this little number in the square brackets, the order in which the cells have been executed in the notebook. So I can see, for instance, here I assigned the value to temp Fahrenheit as the 20th thing that was done in his notebook. And then for number 21, I then printed out the value of temp Fahrenheit. That's cool. It's nice to do that, but I would still say it's not necessarily a good idea to write your notebooks in such a way that the cells have to be run kind of out of order. They should basically be you should try to write things top to bottom so that you start and define everything in order so that if you run from top to bottom through the cells, you get the expected outputs. So then down here, just to check and see what things look like right now, we could say, for instance, the values of temp Celsius and temp Fahrenheit are, and then I could say temp underscore Celsius, temp Fahrenheit. And when I run this, then my print statement will print out this text, then the value of temp Celsius, then the value of temp Fahrenheit from those variables. And I can see, for instance, here, the values of temp Celsius and temp Fahrenheit are 0, 32 degrees. And those are the values that we have assigned earlier. Now, just to make a distinction from something like if you have been working in Excel, where maybe you change the value in a cell of a spreadsheet and it changes the other values. If I was to change temp Celsius to be equal to 20 degrees, I can do that, no problem, reassign it. And if I print out the values of temp Celsius and temp Fahrenheit now, I'm just gonna copy this cell from above. I could also just run it, but I'll just copy paste that. The values of temp Celsius and temp Fahrenheit now, if I run this cell after reassigning the value of temp Celsius, I get the updated value of temp Celsius here, 20 degrees, but the temp Fahrenheit value has not changed, even though I had this equation up here where I had modified it earlier. The value is only modified when I store it in this line where this cell was run. So if I ran the cell again, it would now have the new value of temp Celsius and update the value in temp Fahrenheit. But since I have not run that cell since changing the value of temp Celsius, it's kept its original value. So we can talk now maybe a little bit about some data types before another opportunity to check your understanding. And in terms of what a data type is, it's essentially a characteristic of some data in the program. that relates to how it's represented in the computer's memory and what you can do with it. So for instance, there can be in Python these 4 basic data types, int, which refers to an integer whole number value, float, which refers to a decimal value, str or string, that refers to a string of characters like some text, and then bool, which refers to true or false Boolean values. So we have a way to check that using a function called type that will tell us what kind of data type we have. So we could make a variable called weather forecast and set its value equal to hot, and store that in memory. And then we could also check the type of weather forecast. And if I run this cell after checking the type, then what I would see here is I get back this type as str. Is there a keyboard shortcut for running all the cells in a notebook? That's a good question. I don't actually know whether there's a keyboard shortcut for it. So this is a question that was posted in Slack. What you can do though is if you go up to where it says kernel, there is a possibility to restart the kernel and run all cells. So that clears everything out and runs all the cells from top to bottom. Or you can go to run, and I think you can run all cells from there as well. I don't think there's keyboard shortcuts for those. I think there's only keyboard shortcuts to run like the current cell. So yeah, good question, but you can go up here to the run and to the kernel options if you want to run all the cells. So yeah, one thing I want to just note here about the data type, okay, we assigned weather forecast, we check its type and we see it's a type str, it's a character string, that makes sense. We put a value that's in quotation marks in there, so that's what it should be. Python is a dynamically typed language, so for those of you who may have used other programming languages like C, C++, Fortran, I don't know for Java if Java works this way where you have to declare the data types of a variable before you use it. But what you can see here is that when you do the assignment of a value to a variable in Python, Python will choose the data type that's associated with it when the variable assignment happens. So you don't have to say beforehand that weather forecast is a type string and then assign the value. It dynamically does that when the value is assigned based on what kind of value is passed to it. So we could, for instance, check our type of temp Fahrenheit, just to see another example. And if I run this cell, I see it's a type float, and that makes sense. If we scroll back up to the last time we saw temp Fahrenheit, we saw it had a value of 32.0. That's a decimal number, and sure enough, that's type float. So that's good. And why does the data type matter? Well, there are some things where occasionally data types don't get along. So if we were to do something like try to update the value of temp Fahrenheit with something completely nonsensical, we could say temp Fahrenheit equals temp Fahrenheit. So we're going to use the old value that was stored here, plus 5.0 times weather forecast. And when you try to do this, you get a type error. Why do you get a type error here? Well, temp Fahrenheit is of type float. Weather forecast is of type string, str. And there is no logical way that Python understands to combine a floating point number with a string of characters. It doesn't know whether you want to do some kind of mathematical addition. It doesn't know whether you want to literally take the number 32.0 and then add to it some string of characters. So because of this uncertainty, you basically get a type error. Here it says you can't multiply a sequence by non-int of type float. So it's not necessarily that obvious what the message is, but it's basically saying you can't multiply this value together. If I change this to be 5 times weather forecast and run the same thing, here it was complaining I was trying to use a decimal value and multiply it by some string. So even if I make it an integer value, it now says unsupported operand types for plus. So it says you can't add float and string together. There's no way to combine those values. So you'll encounter, in some cases, a type error. It's possible, and that might be something that causes trouble for you at some point along the road. So let's take one more opportunity here to check your understanding, and we can do this by noting that it is possible to do some math with character strings in Python. So what you should do here is define 2 variables, assign them character string values in Python, and then you can see what happens if you try to do things like add them together, subtract them, multiply them, divide, and if there are any other math operations or operators that work with character strings. So I'm going to clear away our check marks. And again, once you're done with this, once you've defined your 2 variables and played around a little bit, you can maybe put a green check mark to say that, and then we'll continue from there. All right, so I still see the number of green check marks is slowly growing, and that's good. And maybe this is somewhat more open-ended. This might take a little bit more time. If you're still playing around, that's no problem. But the point here was to just define some variables and to see what kind of math operations work. And so we could say make a couple variables called, let's see, let's have one called start. And we could say my favorite food is, and then we could have a variable called end, and I don't know, we could say tacos. And obviously you can do certain things like we've defined those 2. I could do start plus end. And if I run this cell, I see my favorite food is tacos. So plus, when it turns out, when you have 2 character strings, you can add them together. What Python sees that as is it doesn't try to do some kind of math. It just says, okay, I've got 1 character string. I'm just going to add the other one to the end of it. And you can actually do even more than that. I could do my sort of change to things here, saying I'm going to do start plus 5 times end. The parentheses don't really matter here. I'm just adding them for the sake of clarity. And this won't totally make sense, but now you can see my favorite food is tacos, 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 tacos. So I've added that then 5 times to the end of my statement. So multiplication of character strings also works. So if I said I wanted to do print, let's do something to make our taco declaration just exceptionally extravagant. We'll say 80 times the character star. I'm going to print that. Then I'll print out my start plus, I'll take away my 5 times end. I'll just do start plus end. And then I'll add my, oops, I missed my parenthesis. And I'll print out again 80 times the character star. And now when I declare my love for tacos, it will be truly spectacular. And so you can see here, 80 times star just puts the star character 80 times. Then I have my print statement with my declaration of my love for tacos, and then 80 more stars after that. So multiplication works, addition works. What about if I try to subtract? You're going to see that you have a problem here. Subtraction of character strings doesn't really make sense. It's not like even if I had a character string that had the same words in it, trying to subtract the two just is not something that Python knows what to do with. When you add them together, it says, oh, I'll concatenate. I'll put these together into a single thing. When you subtract, it doesn't know how to handle that. And the same thing goes that if you try to do division, it also says that you cannot divide a character string by another character string. You can multiply and you can add, but you can't divide or subtract. And similarly, you cannot raise a character string to an exponent using a power function like that. You also, if you multiply two strings together, it won't work because it doesn't know how to multiply two strings. A number in a character string is okay, and if you want to add two character strings together, that's fine, but you can't subtract or divide or multiply two strings together. All right, we have a little bit here left about doing character input, but I think I'm going to skip that for now. It is available on the course website. You can see how to do this character input there. It's kind of nice because you have this input thing that can ask you a question, you can put in a value, and then you can play with it. You can take a look at that, but I think it would be good for me to stop here and maybe trade with Woko, who might want to do a quick introduction to the exercise. I will note one other thing before I do that. So again, here on the course page, if you look at our lesson, you'll see that you can see basically what we're doing in our notebook is available in the course page with filled in cells, so you can see what the outputs you should look like. Before we go to the exercise, I just want to note that we do have a good coding practice for this week, and I think we'll do a little recording of this video and post it on the webpage so you can see an overview of how this works. But this is basically about choosing good variable names, and there's some bad examples and some good examples of how to name variables, and some ideas for what makes a good variable name, because the same data can be referenced, the same value can be referenced with a bad name where no one understands what you're doing, or a good name where it's immediately clear what that value is supposed to be. So you should have a look here at this good coding practice. We'll try to record a little video about it just so you can get a little bit more of an overview of some good and bad variable names and some of the limitations. But that's there on the course page now. And then we have our first exercise, and maybe for this, I will stop my share and see perhaps if Woko wants to give us a quick overview of the exercise.
Yeah, great. Thanks, Dave. So that was the first Python lesson, and I will now explain the first exercise. So the whole point of this first exercise is to get you familiar with the course environment and write a few lines of Python code to get you started with. So pretty simple. You can find the exercise on the web pages under exercise 1. And the exercise has basically 3 parts. And we would ask you to submit the exercise before the start of the next lesson, because then we will need the information you provide for then organizing the teaching afterwards. So the first task is for you to sign up to GitHub. So GitHub is basically a platform for hosting code and for collaboration. So hub for Git projects, basically. We will talk more about GitHub next week, but in order to get started, you should all sign up. So go to github.com and make an account. And from now on, then all the exercises you will then submit via GitHub. So that's the first task. Then the second task, most of you already have joined Slack, but if you haven't, please do it. So the registered students for this course. And after you have created your GitHub account, we would ask you to go to week 1 channel on Slack and post a message there with your information, because otherwise we won't know what is your GitHub account. So we ask you to post your full name, comma, GitHub username, and then the course code you have signed up for. So Dave would go and put Dave Whip, and then the course code. If you're from Turku or Aalto, you can then just mention your home institution. So you would go to Slack, week 1 channel and post a new message there, so we will be able to extract the information from there. Then finally, the programming part. So we will then cook up some Python, won't be making the jam, but we will be writing some Python code using the JupyterLab environment. So how to get started with that? Once you have then created your GitHub account, you will be able to click on this link on the course pages, and you will be directed to GitHub Classroom, which then helps us to organize the exercises. And using your newly created GitHub account, you can then log in, and then you will see some stuff happening. So what happens in here is that we have a template for the exercise, and then GitHub Classroom creates your personal private exercise repository. So this exercise 1 username is only visible to you and then the course instructors. So then from here you will get the instructions for the programming part of the exercise. And in addition, we have a little pre-course survey for you to fill in so that we can then prepare better for this online teaching this year. So please also answer some questions about your skills, and then also for the following weeks for the group exercises, we'll need some information. So please do that. Okay, and then finally for the programming part of the exercise, instructions are here. I'll shift back to the exercise page for a moment. So in case you start the exercise tomorrow, you have closed everything, so you can find links to CSC notebooks and binder from the exercise page. So from here, you can access again the CSC notebooks environment, and you can click on the link and launch the instance from there. So that is where we will be working with the exercise. I have my instance open in here. So you have there was the notebooks folder, and then there is this folder for the exercises. So I recommend that you would go and work in there. So over at GitHub, you have a set of problems to solve, and I will help you get started with the two kind of problem 0 and problem 1 in here, and then you can read the rest of the instructions from the repository. So basically, we want to write some code. So we want to create a new file for this exercise. So in your JupyterLab, you have few different places. You can launch it from this front page, create a new notebook file, or then from file, new notebook. So then you will, you can just select the default settings. So you will actually see a file with the extension IPYNB in your folder. It's a good idea to always, as the first thing, to rename it. So exercise 1 is the suggested file name, and then you can start solving the programming problems. A couple of practical things with this notebook file is that we have these code cells that you were using previously. You can move them around if you want. And then from top of the notebook in the JupyterLab, you can also switch the cell type to Markdown. We will discuss Markdown next week in more detail, but what it is, it's basically plain text. So I could write problem 1 here, move it above then my solution for problem 1, and then there are also different ways to style the Markdown cells. So this is now Markdown cell, this is a code cell, and then you could start writing your solutions in here according to the instructions. Sorry, over here. So in the first problem, you will define some variables as you learned in the lesson. So we still dream about summer and talk about ice cream and sleeping. In the second problem, you will actually need this input command that is at the end of the lesson. So maybe during the exercise sessions, we could spend some time introducing how this input works if it seems tricky. So you will do a bit of interactive code. And then in the third problem, you will combine these variables that you created and calculate some ratings for your happiness. Checking some data types in problem 4, and then finally creating some outputs that are logical to a human audience based on the variables and calculations you did in the previous problems. And then finally, how to submit. I will show this hands-on. So once you have then solved, you might have here then problem 2 and so on. This has to be the markdown cell, and you can then continue your solution in there. So remember to save your work. And then finally, you can, for now, for the first week, you can download the file to your machine physically as we are in the cloud computer. So you download it to your own computer. Let's just check where it went. There. And then over at GitHub, you have your private repository. So you have this button, add file, upload files. So you can either drag and drop it here, or then go to your file browser and then find your notebook file. I have a very messy. Let's see. Like that. You can just upload it to GitHub, leave a message. If you can also upload only problem 1 if you only solved that. And then commit your changes. So next week, we will also discuss more advanced tools to interact with GitHub using Git, which is the version control system behind. So that's it in a nutshell. Create your GitHub account, tell it to us on Slack, launch your GitHub Classroom repository, do the survey, open JupyterLab, create a file with the problems solved, download it to your computer, and then upload it to GitHub. And if you have any questions, please ask on Slack or come to the exercise sessions here in this same Zoom room on Thursdays and Fridays. That's about it. Maybe does Dave want to wrap up with something general?
I don't really think I have much to add. I suppose I would just like to reiterate that if you do have questions, you can ask them in Slack, or you can contact us directly if it's things related to enrollment in the course or something you don't think is appropriate for Slack. You can send direct messages in Slack as well. So if you want to send a direct message to one of the instructors with a question that is more specifically related to your participation in the course, you can do that there. But I think otherwise, we will have our exercise sessions on Thursday and Friday where you can come and get some assistance on Zoom. This first exercise is meant to be done as a sort of individual exercise, but then from week 2 until the end of the course, at the moment, that plan would be that we'll be working in pairs. And so if you fill in this little survey, this e-form with some information about your experience with programming and things like that, that will help us in making up the groups and making sure that we have a good plan for week 2. If there aren't any other questions at the moment, I suppose that's maybe it for today. And we'll be posting the recording of the lecture online sometime later today once we've had a chance to edit things, and I think I'll try to find some way to blur out things, like if people's names have shown up on different parts of the recording, maybe we can blur some of that stuff out. But otherwise, I think that's it. Thanks for joining us. It would be really great to see you all in person in the classroom, but I do appreciate you being here on Zoom, and I'm sure Volko feels the same. And we'll look forward to seeing you next week for our next lesson.